Nvidia designs the chip. TSMC builds it. But neither can function without 7 companies most investors have never heard of. Together, they control a $135 billion supply chain, and right now, geopolitics is turning it into a weapon. In this episode, we'll answer 3 questions. What are the 7 choke points in chip manufacturing that no one can bypass? Why has 30 years of R&D made these monopolies essentially permanent? And as Washington weaponizes export controls, which equipment makers win and which lose 40% of their revenue overnight? Every advanced chip passes through 7 stages before it works. Design, lithography, deposition, etching, inspection, packaging, and test. At each stage, 1 or 2 companies dominate. Skip any single step, and the chip doesn't exist. Here's what makes this industry unlike anything else: the barriers aren't patents, they're physics. Building an EUV lithography machine requires light at a wavelength of 13.5 nanometers, generated by firing a laser at molten tin droplets 50,000 times per second. Qualification cycles take 2 to 3 years. A chipmaker doesn't just buy a machine, it rebuilds its entire manufacturing process around it. The total semiconductor equipment market hit $135 billion in 2025, up 15% year-on-year. Semi projects $156 billion by 2027. And the single largest driver? AI. For every $100 billion of data center investment, roughly $8 billion flows directly to equipment makers. ASML Holding is a Dutch company with 100% market share in extreme ultraviolet lithography, the technology required to print transistors below 7 nanometers. No EUV, no leading-edge chips. Period. A standard EUV system costs around $180 million. The newest high-NA version? $380 million. Each machine weighs 180 tons, ships on 3 Boeing 747s, and contains over 100,000 components from more than 5,000 suppliers. Carl Zeiss makes the optics. Trump builds the laser. Neither is publicly traded, and neither can be replaced. In 2025, ASML posted €32.7 billion in revenue with €9.6 billion in net income. Its backlog stands at €38.8 billion, fully booked through 2027. In the fourth quarter alone, bookings hit $13.2 billion, with $7.4 billion in EUV orders, nearly double analyst estimates. It took 30 years and over €15 billion in R&D to build this position. No competitor, not Nikon, not Canon, not China's prototype, is within a decade of production-ready EUV. Once ASML prints the pattern, the next 2 steps are deposition and etching. 2 American companies own these stages, but they play very different games. Applied Materials is the broadest player, record revenue of $28.4 billion in fiscal 2025. Applied Materials leads in chemical vapor deposition and bundles tools into integrated modules, the general contractor of chip manufacturing. Lam Research is the specialist. Lam controls roughly 45% of the global etch market, the largest segment in wafer fab equipment. Revenue hit $20.6 billion in 2025, up 27%, with margins above 50%. Its Flex series captured 42% of gate-all-around etch wins, the transistor architecture powering every next-generation AI chip. Combined, Applied Materials and LRCX generated $49 billion last year. Their moat isn't branding, switching equipment mid-process risks destroying billions in work-in-progress silicon. No fab manager takes that gamble. After layers are deposited and etched, every nanometer must be inspected. KLA Corporation is the gatekeeper. Miss a defect at the 3 nanometer node, and an entire production lot worth millions becomes scrap. As chips get smaller, the inspection burden compounds. KLA estimates the 2026 wafer fab equipment market at the mid-$130 billion range, with advanced packaging adding another $12 billion. The financial profile tells the story: fiscal 2025 revenue of $12.2 billion, gross margins above 62%, the highest in the equipment industry. Advanced packaging revenue hit $950 million in 2025, up 70% year-on-year. You can delay buying a new deposition tool. You cannot skip inspection. Before any equipment touches silicon, someone has to design the chip. That software market, worth over $20 billion, is locked down tighter than any hardware segment. Synopsys and Cadence design systems together control over 70% of electronic design automation. Without their tools, Nvidia couldn't design a GPU, Apple couldn't tape out an M-series chip, and Qualcomm couldn't build a modem. Synopsys posted fiscal 2025 revenue of $7 billion, then exploded. Q1 fiscal 2026 revenue up 66% year-on-year, boosted by its $35 billion Ansys acquisition. Cadence guided 2026 revenue to $6 billion with a record backlog of $7.8 billion. These are subscription software businesses with 90% plus gross margins. They don't just sell tools, they sell the language chips are designed in. Switching EDA vendors mid-project is like rewriting a novel in a different alphabet. Now for the company you've almost certainly never heard of. Entegris makes the filters, chemicals, and specialty materials that keep fabs running at the purity levels advanced chips demand. Here's the math that explains why no one switches. At the 1.4 nanometer node, a 1% yield loss can destroy up to $800 million a year for a single fab. Entegris filters prevent that. Their products are a tiny fraction of fab cost, but the price of failure is catastrophic. Revenue was $3.2 billion in 2025, with CMP slurry sales growing 14% and pads up 24%, both outpacing wafer growth. Entegris holds 28% of the semiconductor filtration market, and every leading-edge fab on the planet runs their materials. Let's follow the money. TSMC just announced 2026 capital expenditure of $52 to $56 billion, the highest in semiconductor history, up 30%. 70 to 80% goes to advanced process technologies, 2 nanometer lines, gate-all-around transistors, advanced packaging. Where does it land? ASML gets the lithography orders. Applied Materials and Lam split deposition and etch. KLA inspects every layer. Entegris supplies the materials. And the chip was designed on Synopsys and Cadence software. TSMC isn't the only spender. SK Hynix committed $8 billion for 30 EUV systems by 2027. Samsung is securing 20 EUV machines for its Pyeongtaek megafab. Intel is betting its foundry comeback on high-NA EUV. Every major chipmaker is racing simultaneously, and there's only one supplier for the most critical tool. Now here's where it gets dangerous. In 2024, ASML sold 70% of its deep ultraviolet immersion systems to Chinese customers. EUV was already banned, but Chinese fabs were stockpiling older DUV tools as fast as they could. Washington noticed. In April 2026, bipartisan lawmakers introduced the Match Act, proposing to ban DUV exports to China and prohibit servicing equipment already installed. Machines already in Chinese fabs could go dark. The stakes: in 2024, U.S. equipment makers derived roughly 40% of revenue from China, over $20 billion. ASML's China business dropped from 33% in 2025 to a projected 20% in 2026. China isn't standing still. A domestic EUV prototype was completed in Shenzhen in early 2025, though experts estimate it's a generation behind current ASML tools. Beijing retaliated with rare earth export controls in December 2025. That's not just a counterpunch, it's a reminder that choke points cut both ways. The central tension: Washington wants to choke China's chip-making capacity. But doing so means equipment companies lose their most profitable growth market. The industry is being asked to choose between revenue and national security. Let's put all 8 companies side by side. ASML has the strongest monopoly position but the sharpest geopolitical overhang. KLA has the best margins at over 62%, better than most software companies. Synopsys is growing fastest, with Q1 up 66%. Lam Research has the strongest hardware momentum at 27% revenue growth. And Entegris, while smallest, has the deepest lock-in, no fab risks and $800 million yield loss to save pennies on filters. The key insight: these aren't cyclical commodity businesses anymore. AI has created a structural demand floor. Even in a semiconductor downturn, leading-edge equipment spending is decoupled from the broader cycle. Hyperscalers don't stop building data centers when consumer PC sales dip. The most likely path: continued acceleration, with Semi forecasting the market to hit $156 billion by 2027, a new record for the third year running. The probability of a meaningful downturn before late 2027 is, in my assessment, below 20%, as long as hyperscaler capex holds. Watch these 3 signals. TSMC's quarterly capex: any downward revision signals cooling demand. ASML's quarterly bookings: a drop below €8 billion is the first crack. And the Match Act: full passage removes $20 billion in China revenue from U.S. equipment makers. On catalysts, Intel's foundry turnaround with high-NA EUV is the upside. A hyperscaler capex cut from Meta, Google, or Microsoft is the downside, the entire chain reprices overnight. Upstream, equipment demand pulls through to specialty gases, precision optics, and ceramics that can't scale overnight. Downstream, any bottleneck constrains chip supply for AI clusters, autonomous vehicles, and defense. When ASML can't ship, the entire semiconductor timeline shifts. 7 choke points. $135 billion. And the companies that decide whether the AI revolution gets built or gets bottlenecked. I'm Big Z, follow me, see you in the next deep dive.